Hello, everybody. So today what I will be doing is I will just be taking up the second problem that we had in our tutorial for side 113. So what we're going to begin with is we have what we need to prove. Sine squared theta times cosine squared theta equals 1 minus cosine 4 theta over 8. Now, what's important to notice here is that we're obviously going to use De Moivre's theorem. Sorry, I can't pronounce it. And if you remember the theorem, that just states that if you have cosine theta plus I sine theta to the power of n is equal to cosine n theta plus I sine n theta. And that's basically, it's not quite De Moivre's theorem because we also have the modulus z to the power of n, and here we have the modulus z to the power of n, but we just simplify it. So when we're trying to prove trig identities, this is basically what's going to be it. And in this case, what Ms. Scott told us is that n is going to be replaced with 4. And so from there, that is how we get basically our central equation from which we're going to start. That is cosine theta plus I sine theta to the power of 4 equals to cosine 4 theta plus I sine 4 theta. Now, what we're going to do is we're going to start by expanding our left side right over here. And the way Ms. Scott did it is that first she took it to the power of 2, and then again to the power of 2. But what I'm going to do is I'm just going to start straight away and expand all of it. So to expand it, what we're going to need is we're going to need to remember our Pascal's rule. And if you don't know it, it basically states that if we have a plus b to the power of n, it is going to follow the Pascal's triangle. So what does that mean? So that if n is equal to 2, then the way it's going to turn out is going to be 1, 2, 1. And we see that, right? So if a plus b squared is equal to a squared plus 2ab plus b squared. If we have a plus b to the power of 3, it's going to be 1, 3, 3, 1. And these 3 are the coefficients. So if you have a plus b to the power of 3, it is going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. And also what you can notice is that a cubed becomes a squared, and a and b kind of grows. So if we were to have 4, the rule it's going to follow is the coefficients are going to be 1, 4, 6, 4, 1. And so again, if we just open it up here quickly to the side, so when I open it up on the left side, it's going to be a lot clearer. So what are we going to get? We're going to get a to the power of 4 plus plus 4 a cubed b plus 6 a squared b squared plus 4 a b cubed plus b to the power of 4. And there you go. So now let's expand that here on the left. So let's start. So first we're going to take it to the power of 4. So we're going to have cosine theta to the power of 4 plus 4 I sine theta cosine cubed. And notice how in this case, I is just I, and that's what we're going to add. But in next, and I'll just erase what we have on the left here so that I can continue. Sorry, it's going to take a while. There you go. So now I cube. Now, when the next thing, what's going to happen is that we're going to have I sine squared. And if we remembered, I squared is equal to -1. And that's why what we're going to get next is going to be a subtraction action. We're going to get minus 6. And I squared is -1, so it just disappeared. So we're going to get sine squared theta cosine squared theta. Okay, then the next thing is I cubed, and I cubed is minus. It's also going to be a minus, so it's going to be minus 4 I sine cubed theta cosine theta And finally, we're going to end it off with just sine to the power 4. And I to the power 4 is just 1. And that's why it's going to be plus sine theta to the power of 4. Now, in class, if you remember, Miss Scott had some of these weird equations where it just said, where it was like bracket, and I. And what she meant by that is, if you remember our first proof, what we did is we equated our real part to our real part and our imaginary part to our imaginary part. So in this case, this is an imaginary part, and that's why she had I in brackets. And this is an imaginary part, and that's why this would also be I in brackets. And here, the reason we kind of throw it out is because we know that both of these are going to equate to this part, and that's the imaginary part over here. If we want to look at a real part, which is, we have 4 of them, so we have a real part over here, a real part over here, and a real part over here, that is going to equal to a real part on the right side, which is right over here. So in essence, what we can do is we can throw out our imaginary part, because we know that it's imaginary, and only focus on the real part. So now what I'm going to do is I'm going to rewrite our equation only with our real parts. So now we know that cosine to the power of 4 theta minus 6 sine squared theta times cosine squared theta plus sine to the power of 4 theta is going to equal to cosine 4 theta. Okay, great. Now comes the real tricky part. So what I'm going to do is I'm going to, again, only manipulate our left side. So I'm only going to manipulate my left side. And what's going to happen is there's 2 parts I really want to focus on. And those 2 parts, just like in class, is going to be cosine to the power of 4 theta and sine to the power of 4 theta. Okay, so let's take a look at what we're going to do. Now, while I'm doing this, what I want you to keep in mind is we're going to complete the square. And what do I mean? So we're going to, if you're a plus b squared is equal to a squared plus 2ab plus b squared. And another real important thing that you need to know is another trig identity, which states that sine squared theta plus cosine squared theta is simply equal to 1. So in essence, what we're going to do is we're going to try to manipulate cosine to the power of 4 theta plus sine to the power of 4 theta to somehow get it to be sine squared theta plus cosine squared theta so that it equals to 1. And if it equals to 1, then that makes our life a lot easier. So that's what we're going to do. We're going to somehow manipulate cosine 4 theta plus sine 4 theta to simplify it to 1. So what are we going to do? Well, what we're going to think about is that sine squared theta plus cosine squared theta. So if I rewrite it here, sine squared theta plus cosine squared theta. If we square this, what is it going to equal to? It is going to equal to sine to the power of 4 theta plus 2, because we need to follow what's up here, 2 sine squared theta cosine squared theta plus cosine to the power of 4 theta. Now, looking at this and looking at over here, we can notice that we have 2 terms which are the same here. We have sine to the power of 4 theta and cosine to the power of 4 theta, which are the same. So now what we're going to do is we are, in essence, going to add 0. Now let's see how we do this. So I noticed that what we need to be able to put it into a square, like put it into brackets, is we need to somehow get 2 times sine squared theta cosine squared theta over here, so that we can then have sine squared theta plus cosine squared theta squared, which is just going to equal to 1, because sine squared theta plus cosine squared theta equals to 1. So the way I'm going to do that is I'm just going to simply add 2 sine squared theta cosine squared theta. And now because I added this, I also need to subtract it. And that's why we're going to minus 2 sine squared theta cosine squared theta. And if we look at it, then what we're actually doing is we're just adding 0. So we're not breaking any math rules by just plugging things in there. Because again, 2 sine squared theta cosine squared theta minus 2 sine squared theta cosine squared theta is just 0. So now what we're going to do is, again, as we planned, we can kind of group all of this together and notice that it's the same thing that we have. So this, all of this, and that's one of the straightest lines I've ever done, if you know what I mean. You probably don't. I don't know what I was trying to say there. But this part over here is equal to this part over here. And so we know that sine 4 theta, sine to the power of 4 theta, plus 2 sine squared theta cosine squared theta, plus cosine 4 theta, just simplifies to sine squared theta plus cosine squared theta. And this is just 1, and 1 squared is 1. So in essence, what happens is that all of this part that I've underlined in blue is going to equal to 1. So we're going to get 1 minus 2 sine squared theta cosine squared theta. So what we just managed to do, and I'm just going to repeat, is we took our cosine 4 theta, sine 4 theta, I took it down here and I manipulated a bit by adding 2 sine squared theta cosine squared theta and subtracting 2 sine squared theta cosine squared theta. And I made cosine to the power of 4 theta plus sine to the power of 4 theta into 1 minus 2 sine squared theta cosine squared theta. If you have any questions afterward, because this is a YouTube video, you can post it. You can ask me in the comments and I will try to respond or make another video. So then let's rewrite our equation. So what we're going to get is, because again, cosine 4 to the power of 4 theta and sine to the power of 4 theta is replaced with 1 minus 2 sine squared theta cosine squared theta. So let's rewrite what we have. So then we're going to get 1 minus 2 sine squared theta cosine squared theta minus 6 sine squared theta cosine squared theta. And again, this is just this. So these two are the same. And again, it's because we replaced cosine 4 theta and sine 4 theta with 1 minus 2 sine squared cosine squared theta. And all of this is equal to cosine 4 theta. Okay? Cool. Let's get some more space right over here. So now let's simplify some stuff. And I just mean let's add negative 2 sine squared theta cosine squared theta and 6 sine squared theta cosine squared theta. So we're going to get 1 minus 8 sine squared theta cosine squared theta is equal to cosine 4 theta. And I just realized that this looks like this is to the power of 4. That is not what I meant. It is 4 theta, cosine 4 theta. Now, what we can do is we can manipulate this a bit. So what I'm going to do is I'm going to bring negative 8 sine squared theta cosine squared theta to the other side and bring cosine 4 theta to my left side. So we're going to get 1 minus cosine 4 theta is equal to 8 sine squared theta cosine squared theta. And finally, we're going to divide both sides by 8. And we're going to get 1 minus cosine 4 theta over 8. And again, a really straight line. I think that's going to be something reoccurring, is equal to sine squared theta cosine squared theta. And wow, look at that. This seems very, very familiar to what we had to prove up top. And there you go. That's what we did. Again, if you have any questions, please put them in the comments or just DM on the Discord or DM me specifically. That would probably be the best solution. And then I can answer or maybe make another video to clear up all those confusions. Thank you very much, and I hope this helps.